Okay, so today we are going to talk about Pythagorean theorem, which is mostly a review for most of you. We've also been using it in this class quite a few times, so we've kind of already talked about some of this stuff. So Pythagorean theorem is this. It's a squared plus b squared equals c squared, and it's only used in right triangles. So we typically use it to find a missing side of a right triangle. So as far as what the letters represent, we already know that a and b represent the legs of the triangle, and we know that C represents the hypotenuse. So C is kind of the important one. It's always the one across from the 90-degree angle, so you got to make sure you identify that correctly. It's also going to be the longest side, so it'll be the largest side of all three of them. So let's practice. Before we do some examples, just wanted to point out some vocabulary here. You're going to hear me say Pythagorean triples in this section. A Pythagorean triple is just a set of three numbers, no decimals, so it's just three whole numbers that work for Pythagorean theorem. So for example, 3, 4, 5 is a very common Pythagorean triple, because if you did this, so 5 would have to be the hypotenuse because it's the biggest one. So if you did 3 squared plus 4 squared, you would get 5 squared. So 3 squared is 9, 4 squared is 16, and if you add those together, you do get 25. So those are just three numbers that work. You don't have to memorize these, but it is helpful if you recognize some of them. Eventually you'll get to a point where you do. And we're also going to do a couple examples where it's asking you whether or not the sides make Pythagorean triples. So we'll talk about that in a second. So, in this first example here, it says use Pythagorean theorem to find x, then state whether the sides form a Pythagorean triple. This is supposed to say triple. So state whether the sides form a Pythagorean triple. Okay, so here's what we're going to do. We're basically just going to do Pythagorean theorem. So let's set that up. So we can call this one A and this one B, and then x would have to be c because it's across from the 90-degree angle. That would be our hypotenuse. Now, as far as a and b goes, you could switch those. It doesn't matter where you put a and b. So it would be 5 squared plus 12 squared equals x squared. And then we're going to go ahead and solve this out. So 5 squared is 25, 12 squared is 144. And if you add those up, 25 plus 144 is 169. And then the last step here would be to square root both sides. So if you take the square root of 169, you get 13. So that is the value of x. X equals 13. And then to answer that second question, it says state whether the sides form a Pythagorean triple. The answer to that would be yes, because you ended up with a number that's not a decimal. So for example, 5, 12, and 13. That is a Pythagorean triple because none of those numbers are decimals. It's also located in that list of triples up here. So if you look up here, 5, 12, 13, it's on that list. So it's a Pythagorean triple. Okay, for the second example, same thing. We're going to go ahead and set up Pythagorean theorem. So this would be A, this would be B, or you could swap those if you want to. And then this time, we're actually given the hypotenuse. The hypotenuse is 14. So when we set it up, it's going to look a little bit differently. So it would be 7 squared plus x squared equals 14 squared. So let's go ahead and square those. That would be 49, and then 14 squared is 196. And then because of the setup here, we are going to have to subtract from both sides. So we're going to go ahead and do that. So minus 49, minus 49. And when we do that, we end up with 147. So x squared equals 147. And then we're going to go ahead and square root both sides. Now, normally we would just type this into a calculator and it's going to be a decimal, right? So because it's a decimal, we're actually not going to use decimals. If you read the directions here, it says do not use decimals. We're going to be simplifying the radical instead. So we did this yesterday. We're just going to go ahead and break up that 147. So to do that, let's think about the factors of 147. So this is kind of a tricky one. You might have to take your calculator and just start dividing by a bunch of numbers. But the one that works is 49. So 147 can break up into 49 and 3, because 49 times 3 equals 147. And then to simplify that, it would turn into 7 square root 3, because the square root of 49 is 7. So that is the value of x. Now, the other question here was whether or not it makes a Pythagorean triple. And the answer to that would be no, it's not a triple because we ended up with a number that's not a whole number. So we ended up with this, square root of 147. That equals 7 root 3. That's not a whole number. That would be a decimal. So that would not be a Pythagorean triple. Okay, so on this page, there's 2 you try problems up top there. You go ahead and try those. So we're going to pause the video real quick. You guys can try those problems on your own, and we will put up the answers in just a couple minutes. So go ahead and try those. Okay, so I'm going to go ahead and show the answer to both of those now. So here's what you should be getting for those. So for the first one, once you solved for Pythagorean theorem, you ended up with the square root of 52, and that breaks down into 4 times 13. So it would be 2 square root 13. And because we ended up with a non-perfect square, that means that this is not a Pythagorean triple. And then in the second one, we ended up with 4. So if you did Pythagorean theorem correctly, you should be getting 4 for that. And because we ended up with a nice perfect number, that means yes, this was a Pythagorean triple. Okay, so now we are going to talk about the Pythagorean theorem converse. Okay, so the Pythagorean theorem converse, it's kind of the opposite of Pythagorean theorem. That's usually what converse means, right? So typically when we use Pythagorean theorem, we can only use it if we know without a doubt that this is a right triangle. So see how we have this 90-degree box here? We know that this is a right triangle, so we were able to go ahead and use that Pythagorean theorem. So with the converse, you're not necessarily going to know that it's a right triangle. So if you look at our first example here, we don't know that that's a right triangle. They didn't tell us that that's a 90-degree angle. There's no box there. So what we're going to do instead, they actually gave us all 3 sides. We're going to use Pythagorean theorem to try to figure out if this is a right triangle or not. And it's pretty simple. So the first thing you want to do is figure out which side would have to be the hypotenuse. And that's just going to be the longest side. So you just have to figure out which number is the biggest, basically. And then you're going to plug in all 3 sides into Pythagorean theorem, and you're just going to see if it works. So let's take a look at this first one. So you got to figure out first which side is going to be your hypotenuse. Now, I know that it looks like it's going to be that one, but you do want to just make sure by actually calculating it out. So we need to kind of estimate what the square root of 113 is. And you can just put that in a calculator if you want to, like just in your calculator type in the square root of 113. We just want to make sure that that's actually going to be the longest side. And it is, because the square root of 113 is approximately 10.6. So that's definitely the biggest side, right? It's bigger than 8 and 7. So that would be our C. And we're going to plug all these sides into Pythagorean theorem. So let's call this one A and this one B. And we're just going to put them into A squared plus B squared equals C squared. So I'm going to go ahead and do that. It's going to be 8 squared plus 7 squared equals, now this one's kind of interesting because it's a radical, right? We talked about radicals a little bit yesterday. So this is how I'm going to write it. I'm going to write the square root of 113 squared. And we'll talk about how to deal with that in a second. So for right now, let's just start simplifying some of this. So 8 squared is 64. 7 squared is 49. And the square root of 113 squared, remember yesterday when we were doing stuff like this, I'm going to rewrite this like this. It's the square root of 113 times the square root of 113. That's what it means to square something, right? It's just this number multiplied by itself. And remember yesterday when we took a radical and we multiply it by itself, what happened was the radical symbol just canceled out. And this became a regular 113 with no radical symbol over it. So this would just equal 113. So again, when you square a radical, it just kind of makes that radical go away. We talked about why that happens yesterday, so I'm not going to really get into that right now, but that's what's going to happen here. So the square root of 113 squared, it's just going to be 113. Okay, and then we're just going to go ahead and see if these actually add up to 113. So 64 plus 49, that does in fact equal 113. So since this worked out, we would say yes, this was a right triangle. So because that was the question here, right? It says tell whether each triangle below is a right triangle. So we're going to go ahead and say yes. This one is definitely a right triangle because Pythagorean theorem worked for this. So let's go ahead and try that next one. Once again, we want to make sure we know which side is supposed to be the hypotenuse. And obviously it looks like that one's going to be the hypotenuse, but let's go ahead and actually make sure that that works. And you can just do that in your calculator. Like in your calculator, you can do 4 times the square root of 95. Just like type it into your calculator. Or you can do the square root of 95 and then you can multiply it by 4 and just get what that number would be as a decimal. So if you calculate that out, I'm just doing it in my calculator right now, this is going to be approximately 38.987, and then it continues. So that's definitely the biggest side, right? So this is definitely the hypotenuse. So now we're going to go ahead and plug everything into Pythagorean theorem. So this would be C, and then I'm just going to call this A and this B. So here we go. I'm going to plug it into a squared plus b squared equals c squared. So we're going to have 36 squared plus 15 squared equals, I'm going to write it like this, 4 times the square root of 95 squared. So I like to put those in parentheses like that when they have radicals. Okay, so let's try to figure out what this is. So 36 squared, you can just use a calculator for that if you need to. That is 1296. And then 15 squared, that's 225, equals. And then this one I'm going to do off to the side over here because it's a little complicated to square something like this. So again, remember this means 4 root 95 multiplied by itself. So I'm going to do this, 4 root 95. Okay, so one thing we can do with these 4s, that's just going to be 4 times 4. So that's 16. And then the square root of 95 times the square root of 95, remember that's just going to turn into a regular 95. It's just going to take away that radical symbol. So what we're left with is 16 times 95. So you would just have to multiply those together, and that equals 1520. So that's what we're going to put over here, 1520. Okay, so now we're going to add these up. If we add up 1296 and 225, that actually equals 1521. So this did not work, right? 1521 does not equal 1520. So this would be not a right triangle. In order for it to be a right triangle, those would have to be equal. And it just didn't work this time. So we're going to say, no, this is not a right triangle. Okay, so that's how you handle that. You basically just do Pythagorean theorem and you figure out if it's equal to each other or not. Multiplying these radicals can be a little strange, but we did some of this yesterday. So it kind of helps just to write it all out like this. Okay, let's go to the page. So there's a couple here for you to try. So if you would like, you can pause the video right now and you can try those on your own. I am just going to put up the answers in the video in a minute, so feel free, pause right here, try these examples on your own really quick, and then when you're ready to check your answers, you can push play, and you'll see the answers in just a second. All right, so here are the answers to these two. So for this first one here, this one was yes, it is a right triangle, and I have all the work here so you can see what I did. Feel free to pause it if you need to take a look at this work. But I multiplied this out over here, and that was equal to 306. And then when you add these together, that's also equal to 306. So that one would be a yes. And then this one would be no. This one was actually really nice because you didn't have any radicals to work with. So it was just, normal numbers. And when you do Pythagorean theorem, it did not equal each other on the same side. So this would be no, it is not a right triangle. All right, and then the last thing we're going to do with Pythagorean theorem, you can actually use it to classify triangles and figure out if they are obtuse or acute. So we're going to learn how to do that. So obviously we can use it to figure out if they're a right triangle. That's kind of what we did up here, right? We were figuring out if these are a right triangle. If it's not a right triangle, we can figure out whether it's going to be an obtuse triangle or an acute triangle. And here's how you do that. So first, you want to make sure that the side lengths could actually even make a triangle. And we haven't talked about that before, but in order for side lengths to make a triangle, what you would do is you would add the two smaller sides, and you want to make sure that their sum is bigger than the third side or larger than the third side. So for example, before we talk about step 2 right here, let's just do that for this first example. We want to make sure that the side lengths could actually make a triangle. So, and just to show you over here what I mean by that. So let's say we have this side and then I have this side right here. In order for me to make a triangle out of this, I would need this side to be big enough, basically. Like if it's too short, let's say it looks like that. If it's too short, there's really no way for me to turn this into a triangle because this side's just too short. Like even if I tried to bring this side down and try to match it up over there, these two sides together would just be too short. They wouldn't end up touching each other. So the way that we figure out if it's a triangle, you take the two smaller sides and you add them together, and their sum has to be bigger than this third side. Otherwise, it's just going to be too short to even make a triangle. So let's verify that with this. If I take the two smaller sides, which would be 4.3 and 5.2, and I add those together, that would give us 9.5. That's definitely bigger than 6.1. So this does make a triangle. So it's definitely going to make a triangle. And then the next step is to figure out what kind of triangle it is. So to do that, we basically do Pythagorean theorem. So what we're going to do is plug in for A, B, and C in Pythagorean theorem, and we're going to see what happens. And here are your 3 possible outcomes. So if we plug it in for Pythagorean theorem, and this is what we end up with. If c squared is equal to a squared plus b squared, well, obviously we know that that means it's a right triangle, right? If both sides are equal to each other, that means it's a right triangle. That's kind of what we're used to dealing with. If c squared ends up being bigger than a squared plus b squared, that means the triangle is obtuse. So that means the triangle is going to look something like this. It'll have an obtuse angle in it. Right, I'll draw a little right triangle here. Right triangles look like that. And if c squared is smaller, so if it's smaller than a squared plus b squared, that means it's going to be an acute triangle. And acute triangles have all acute angles, something like that. That actually almost looks like a right triangle. Let me fix that a little bit. Okay, so let's go ahead and figure that out for this first example. So here we go. We're going to basically just do Pythagorean theorem. So here's our 3 side lengths. We already figured out that they'll definitely make a triangle, right? They're long enough to make a triangle. Now we're going to figure out what kind of triangle. So the first step is to label A, B, and C. Now we know that 6.1 has to be C because that's the biggest one. So then we can just call these A and B. And then we're just going to do Pythagorean theorem. Now when I do these problems, I like to actually write Pythagorean theorem kind of backwards like this. I know we're not used to seeing it like this, but I like to put the c squared first. And that's because it's easier to remember the rules if you do it that way. See how these rules have c squared going first? So that's why I write the c squared first. So let's plug in the numbers here. And we're going to put 6.1 right here. 6.1 squared equals 4.3 squared plus 5.2 squared. And then we're just going to do this math and we're going to see what happens. Okay, so, and you can use calculators for this, right? You can just square these numbers in your calculator. This is going to give us 37.21. So that's going to be equal to 4.3 squared is 18.49. 5.2 squared is 27.04. And then we need to add these together. So if you add those together, we get 45.53. And then if we look at this one, we're going to bring that down, 37.21. And then what you want to do, remember this was our c, right? So this was c squared. This was a squared plus b squared over here. You want to compare these numbers. So if you look at c squared, 37.21, that is smaller than this, right? This is smaller than 45.53. That means if we look at our rules up here, this would be an acute triangle because c squared was less than a squared plus b squared. So since it's less than, we're going to say that this is an acute triangle. And that's really all you have to do. You just do Pythagorean theorem and you compare your final numbers here. If c squared is less than all of this, it's acute. If c squared is bigger than all of this, it would be obtuse. And if they're both equal to each other, it would be a right triangle. So let's go ahead and do some more examples. Okay, so you can try these on your own if you want to, or you can follow along with me. I think I'm just going to do these in the video. So go ahead and try. If you would like to try on your own, feel free to pause here, or you can just continue watching. So we're going to first verify that these segments will actually form a triangle. That's really quick to do. You just take the two smaller ones, you put them together. 3 plus 4 is 7. 7 is definitely bigger than 6. So they do make a triangle. I'm going to put check mark triangle. Those do make a triangle. Now we're going to figure out if it is acute, right, or obtuse. So to do that, we just figure out which one would be A, B, and C. 6 would have to be C. That means these could be our A and B. And then we're going to plug them into Pythagorean theorem. And again, I like to write Pythagorean theorem backwards when I do this because I like the c squared to go first. So we're going to put 6 squared equals 3 squared plus 4 squared. And this is going to give us 36 over here. 3 squared is 9. 4 squared is 16. And then if we add these together, that would give us 25. So if I compare my numbers, 36 is bigger than 25. That means that this is an obtuse triangle. And that's because c squared was bigger. All right, and then the next one, same thing. Let's go ahead and verify this really quick. So we can add the two smaller ones. That's going to give us 4.9. So that's definitely bigger than 3.5, so we're good to go. And let's go ahead and do our Pythagorean theorem. This would be C, and then you could just call these A and B. So I'm going to do c squared first. So 3.5 squared. And we're going to set it equal to 2.1 squared plus 2.8 squared. And then we're just going to square all of these numbers and figure out what happens here. Okay, so I went ahead and squared the numbers so you can see what they equal here. And then if I add these up, this is going to be 12.65. And if I compare these, this is less than 12.65, so that means this is acute. Okay, and the last thing we're going to do is look at some examples of this when we're working with things that have radicals in them. So this is kind of the same setup. It looks a little bit different than these examples up here, but it's just formatted differently. They're asking us to determine if the three given lengths would form a triangle, and then if they do, we're going to classify that triangle as acute, right, or obtuse. So we're basically doing the same thing we did up here, but we just want to be careful with these radicals. So first of all, you want to make sure you know what the biggest side actually is. And the biggest side, sometimes it's hard to tell by looking at it because of this radical. So what I recommend doing is calculating out what that would be as a decimal. If you type that in your calculator, the square root of 67 is approximately like 8.2, right? I think it's like 8.18. So you can type that, and you can just type that in your calculator, square root of 67, and just figure out what that decimal would be. And 8.2 is what it is approximately, which means this right here would actually be our C. That is the biggest side. So we do need to make sure that this actually is going to form a triangle. So let's add the two smaller sides really quick. If we add those up, that's going to be about 12.2, which is definitely bigger than 9. So they do form a triangle. Now we need to figure out what kind of triangle. So we're going to plug into Pythagorean theorem. So we know that this is C, which means I can call this A and this B. So let's go ahead and do that. And again, I'm going to put the c squared first because that's how I like to do these. Over here, I'm going to put a squared plus b squared. And then c squared is 9. So we're going to put 9 squared. And then I'm going to write it like this. The square root of 67 squared plus 4 squared. And then we're just going to calculate all of this out. So 9 squared is 81. Remember, when you square a radical, it's just going to cancel out the radical symbol, and this is just going to become a regular 67. So that's always going to happen. Anytime you square a radical, that's what's going to happen. And then we're going to do the 4 squared, which is 16. And then we can add these up. That's going to give us 83. And if we compare that to 81, 81 is less than 83, so this would be an acute triangle. Okay, and then we have one more example over here. And once again, you want to be really, really careful. You want to make sure you actually calculate that radical side. Make sure you know what it would be as a decimal. Okay, so let's take a look at that. So we're going to calculate this out. So in your calculator, you want to actually figure out what that is. You can type it all in at once if you want to, or you can just do the square root of 43 and then multiply it by 6. However you want to do that, but we do need to figure out what this would be as a decimal. And once you do that, once you calculate it out, it is approximately 39.3. So that means that this would actually be the biggest side, right? 39.3, that's bigger than these two sides. So that would be the biggest side. We're going to call that C. And we're going to go ahead and make sure that this actually adds up to a triangle first. We're going to add these together. 24 plus 30, that's 54. 54 is definitely bigger than 39.3. So this does make a triangle. And now we're going to do Pythagorean theorem. So let's go ahead and label everything. I'm going to call this one A and this one B, and we already have our C labeled. So I'm going to fill everything out. I'm going to put C squared first, and then my A squared plus B squared. So this would look like this. C squared is going to be a little weird. We're going to have 6 times the square root of 43 squared. So we'll deal with that in a second. And then over here, we're going to have 24 squared plus 30 squared. Okay, so to do 6 times the square root of 43, it might help to actually write it all out. So remember, this is the same thing as like 6 root 43 times 6 root 43. You're just multiplying it by itself. So we can multiply the 6's, that's 36. And then when you multiply the square root of 43's, it's just going to turn into a regular 43. So this is going to be the same thing as 36 times 43, and if you multiply that out, that equals 1548. So this side over here is going to be 1548, and then this other side we can go ahead and do this. 24 squared is 576, 30 squared is 900, and then we can just go ahead and add those up, and that's going to give us 1476. And if we compare these here, the C squared is bigger than that other side. So that means that this is an obtuse triangle. Okay, so that is how you do this, and that's it for the notes. So now you're going to go ahead and do that 9.1 homework sheet. It says 9.1 homework on it. That's